Welcome to your second lesson of online chemistry. Last time we learned about ionic compounds, and we're going to continue with that today, and we're going to learn some slightly more complicated types of ionic compounds. This is ionic compounds part 2. So I'm going to start this lesson just like I started the last one by working through an example. So let's look at, again, ionic compounds are made by metals and nonmetals. So I'm going to start with the metal calcium, which is Ca, and oxygen, which is O. Calcium, you should know, has 2 valence electrons. Oxygen has 1, 2, 3, 4, 5, 6. Now, if you remember the octet rule says that an atom is happy, it's stable, if it either has 0 valence electrons or 8 valence electrons. So calcium right now has 2 valence electrons. So it's going to want to lose 2. Because it's going to be much easier for it to get to 0 than to 8. Oxygen, on the other hand, has 6 valence electrons, so it's going to need to gain 2 electrons, because it's going to be easier for it to gain 2 than to lose 6. So what happens here is very similar to the example you saw in the last lesson, but instead of 1 electron being donated from one atom to the other, we have 2 electrons that are going to be donated. So calcium is going to give 2 electrons over to oxygen, and that way both elements are happy because calcium now has an empty octet, so 0 valence electrons, and oxygen has a full octet, 8 valence electrons. Now, if you remember from the last lesson, we're not done. We need to add the charges. Now, calcium normally has 20 protons and 20 electrons. But it just lost 2 electrons, which means it's down to 18. And here it's where it's different from the previous example. Instead of having 1 extra positive charge, it now has 2 extra positive charges. So we say that calcium is a 2 positive ion. So it has a charge of 2 positive. Oxygen, on the other hand, started with 8 protons and 8 electrons, but it gained 2 extra electrons from the calcium. So now it's actually at 10 electrons. So just like calcium has 2 positive charges, oxygen has 2 negative charges because it's got 2 extra electrons. So this is how we would write calcium and oxygen as ions. Now I'm going to move on to a more difficult example where the number of electrons that one atom needs and the number of electrons that another atom needs don't match, and you'll see what I mean by that. So I'm going to use this time the metal sodium and the non-metal oxygen. So again, we start by figuring out how many valence electrons each atom has. Sodium has 1 valence electron. Oxygen has 6 valence electrons. Okay, so again, same process as before. Sodium needs to lose an electron in order to satisfy the octet rule, and oxygen needs to gain 2 electrons. This is where you should sort of be scratching your head and saying, wait a minute, now what do I do, right? Because these don't match. Sodium only has 1 electron to give up, but oxygen needs to gain 2 electrons. So we'll start with this sodium donating its electrons over to oxygen, or its electron, because it only has 1. And now that sodium is happy, right? Sodium is all by its lonesome. But oxygen's not done. Oxygen has 7 valence electrons now, and it really wants 8. It needs another one. So what do? We bring in a second sodium atom, and we can do that. So I bring in a second sodium atom, and sodium is also going to donate its electrons. So we'll have, in the end, 2 atoms of sodium with an empty octet, and that'll give us 1 atom of oxygen with a full octet of 8. But again, just like before, we're not done. We're not done until we've put in the charges. So this sodium atom lost 1 electron. So if it lost 1 electron, that means it has a positive charge. This sodium also lost an electron, which means it has a positive charge. Now this oxygen atom gained 2 electrons, one from each of the sodiums. So now it has a 2 negative charge. Okay? So there are 2 sodiums, each with a positive 1 charge, and 1 oxygen with a 2 negative charge. And I can sort of check that I did this right, because if I did this right, all of the charges should balance. 2 negative charges in total, 2 positive charges in total. So that's my way of self-checking that I did this correctly. So what I've drawn here are the ions, right? The ions that are produced when sodium and oxygen come together. If I wanted to write sodium and oxygen in a formula as a compound, I would write it like this. Na, we always put the metal first, 2O. And what that shows me is that I need 2 sodium atoms for every 1 oxygen atom. So let's work through one more example. This time I'm going to use the metal calcium and the non-metal bromine. I know that calcium has 2 valence electrons and bromine has 7. So I'm going to start the same way I did before, which is by figuring out which atom needs to gain electrons, which atom needs to lose electrons, and how many of each. So calcium has 2 valence electrons. It's going to be much easier for it to lose 2 and get to 0 than to try and gain 6 and get to 8. So calcium needs to lose 2 electrons. Bromine needs to gain 1, because if it has 7, the easiest thing is to gain 1 electron. So we start the same way we did with the previous example. We know that calcium can very easily just give its electron over to bromine and make bromine very, very happy. So now bromine has a full octet of 8 valence electrons. There's a problem, and it's a similar problem to over here, which is that we're not done. Bromine's happy, but calcium isn't. Calcium still has this extra electron that it's looking to get rid of. So what do? We add a second bromine to take it. So this time we need 2 bromine atoms. Bromine has 7 valence electrons. Calcium is so relieved. Now calcium can get rid of its other electron and give it over to bromine. So what are we left with? Well, we're left with 1 calcium atom. Calcium is now empty, which makes it very happy. And it lost 2 valence electrons. So the lost 2 electrons, that means it now has a charge of 2 positive. Remember, when you lose electrons, you end up with a positive charge. When you gain electrons, you end up with a negative charge. So we have calcium that looks like this, and we have 2 bromine atoms. Each bromine atom is very happy with a full octet of 8. Now, if bromine started with 7 valence electrons and now has 8 valence electrons, it's only gained 1. So each bromine atom has a negative charge. And again, I can check, does that make sense? Well, calcium has a 2 positive charge. And I have 2 bromine atoms, each with a negative charge, 2 positives, 2 negatives. If that balances, I did something right. And I can again write this like a formula. So if I wanted to know what's the formula for the ionic compound that calcium and bromine can make, well, I need 1 calcium to bond with 2 bromine. All right, so this tells me that it's going to take 2 bromine atoms to bond with a single calcium.